The character class. In this video, we will continue exploring char values and the character class. We'll start things off by reviewing the difference between strings and chars. Recall that a string is a sequence of characters. For example, the string hello contains 5 characters, H, E, L, L, and O, whereas a char is just a single character. When making a string, we use double quotations to signify that. For chars, we use single quotations. When we want to compare strings, we use the dot equals method, whereas when we want to compare chars, we use the double equals operator. Another fact about chars that hasn't been discussed is the fact that every char is a number. What do I mean by that? When our code gets compiled, every character in our program gets converted to a number. Now you might be wondering, what number do they get converted to? This is where the ASCII table comes in. The ASCII table, which can be found on www.asciitable.com, tells us what number each character in the program translates to. Now you may notice on the table that there are 4 sections, and in each section we have at least 4 columns. For this course, the 2 columns we're most interested in are the 4th column, which contains every character that can be entered into a Java program, and the 1st column, which tells us the number that each of those characters get translated to when the program gets compiled. A few things you'll want to notice about this table. Firstly, the space character gets translated to the number 32. The 10-digit characters translate to 48 through 57. The 26 uppercase letters translate to 65 through 90. And the 26 lowercase letters translate to 97 through 122. Now, you do not need to memorize this because the ASCII table will always be available to you through the internet. However, I bring this up just so that you notice that the special categories of characters are all grouped together. This is something you'll be able to take advantage of in the future when we work on more advanced programs that require you manipulating characters and their ASCII numbers. Now, to our compiler. Java does provide a way for us to determine through code what the ASCII value is for each character. For example, suppose I declare a char value and set it equal to lowercase b. Now suppose I want to determine through code the ASCII value of lowercase b. What I would do is then cast that char value to an int and store the result inside an int variable. When I print out that int variable, the ASCII value will get printed out. Thus, when I print out ASCII, 98 gets printed out because 98 is the ASCII value for lowercase b. Something else Java also allows us to do is arithmetic with ASCII values. For example, here you see me declaring an int called diff, and I set it equal to the difference between uppercase E and uppercase A. What this line of code will do is it'll take the ASCII value of uppercase E, which is 69, and subtract the ASCII value of uppercase A from it, which is 65. What's 69 minus 65? 4. Thus, when we print out diff, 4 gets printed out. We can also perform addition with ASCII values. For example, suppose I declare an int value and set it equal to uppercase A plus 5. What this line of code will do is it'll add 5 to the ASCII value of uppercase A, which is 65. So, in other words, ASCII gets set equal to 65 plus 5, which is 70. Now, suppose I want to know what character is associated with 70. What char has the ASCII value of 70? Well, to determine that, I'm going to cast that int back to a char. I'm going to take ASCII, cast it back to a char, store it inside the char variable. Then, when I print the char variable out, the character associated with 70 will be output, which is uppercase F. The next topic we're going to explore are escape sequences. What is an escape sequence? Characters with a special meaning. They all begin with a / and are treated like a single character. For example, /n. When /n appears in a string, this means insert a new line. All right. Next, /t. When /t appears in the string, that means indent or press tab. Then there's / single quote. This is what we use when we want to actually output the single quote. Then there's / double quote, which is what we use when we actually want to output double quote. Then there's forward slash forward slash, which is what we use when we actually want to output a forward slash. We will demonstrate each of these in code. So for example, consider this line where we're printing out line 1 and line 2. Notice that forward slash n is inserted in between line 1 and line 2. What this does is that it'll move the cursor down to the next line after line 1 gets output. Thus, when this code gets executed, this will be our output. Line 1 appears in the first line, cursor drops down to the next line, then line 2 appears in the second line. Now, consider this line of code. Notice that forward slash t appears after the A and after the B. Thus, an indentation will get inserted after the A and after the B, thus giving us this as our output. A, indent, B, indent, C. Now, consider this line of code. Notice that forward slash single quote appears both before and after uppercase A. Thus, when we execute this program, you'll see that a single quote will be inserted before and after uppercase A. Now, consider this line of code. Notice that forward slash double quote appears before and after yes exclamation point. Thus, when we execute this line of code, double quotation marks will appear before and after yes exclamation point. Now, consider this line of code. Notice that forward slash appears in between the words desktop and exams. This is so that the forward slash will actually appear in our output. Thus, when we execute this program, desktop forward slash exams will get printed out. We'll close this video out by discussing the character class. Now, what is the character class? A Java class that provides many useful static methods that can be performed on char values. Now, after reading that, you might be wondering, what is a static method? What is a class? For now, don't worry about that. We will explore the definitions of those keywords later on in the course. For now, all we need to focus on is how the character class is being used. So, to demonstrate, we'll start by declaring a scanner object that we're going to use to collect input. Then we're going to prompt the user to enter a single char. Then we're going to take the user's input, store it in a char variable. Now, suppose I want to determine whether or not the user entered a letter or not. I can determine this using the character.isLetter method. Character.isLetter returns true if the parameter is a letter and returns false if it is not. So in this case, if what the user entered was a letter, character.isLetter will return true, and thus we'll simply print out a letter. If it returns false, we'll simply output not a letter. So let's execute. Program says enter a char. I type in lowercase n. Obviously, lowercase n is a letter, thus a letter gets output. Now, suppose I execute this again. Enter a char. I enter uppercase G. Obviously, uppercase G is a letter, thus a letter gets output. Suppose I run the program again. This time I enter the number 4. The number 4 is not a letter, thus character.isLetter returns false, thus not a letter gets output. Now suppose I execute this program again, and this time I enter a question mark. Once again, question mark is not a letter, thus character.isLetter returns false, and not a letter gets output to the program. Now suppose I want to be able to determine if what the user entered is a digit or not. Well, in this case, I would use the character.isDigit method, which returns true if the parameter is a digit and returns false if it is not. So let's say I run this to output a number if character.isDigit returns true, and not a number if it is not, if it's false. So let's run it, enter a char, I enter the number 5. Obviously 5 is a digit, thus character.isDigit will return true and output a number. I run the program again. This time I enter uppercase Z. Obviously Z is not a digit, thus character.isDigit will return false, and thus not a number will get printed out. Now, suppose I want to be able to determine if what the user entered is either a letter or a digit. Well, in that case, I would use the character.isLetter or digit method, which returns true if the parameter is a letter or a digit, and returns false if it is neither of those. So To complete this program, if character.isLetter or digit returns true, we'll simply output capital L or capital D exclamation. If it is not, we'll simply output neither. So let's run it. Enter a char. I type lowercase f. Obviously, f is a letter. Thus, character.isLetter or digit will return true. L or D gets printed out. Suppose I run the program again. This time I enter the number 6. 6 is not a letter, but it is a digit. So once again, character.isLetter or digit will return true. Thus, L or D will get printed out. Now, suppose I run the program again. This time I enter the pound sign. Obviously, pound sign is neither a letter nor a digit. Thus, character.isLetter or digit will return false, and thus neither will get printed out. Now, we've already seen how to determine if a character is a letter or not. Turns out, we can get even more specific than that. We can determine if a character is a lowercase letter or not. We do that using the character.isLowercase method, which returns true if the parameter is a lowercase letter and returns false if it is not. So for this code, if it returns true, we'll simply output is lower. If it returns false, we'll output not lower. So let's run it. We enter a char. I enter lowercase h. Lowercase h clearly is a lowercase letter. Thus, the method will return true, and is lower will get printed out. Suppose I run the method again. This time, I enter uppercase h. Uppercase h is not a lowercase letter. Thus, character.isLowercase will return false, and not lower will get printed out. Now, suppose I run the program again. This time, I enter the $ symbol. Obviously, the $ is not a lowercase letter. Thus, character.isLowercase will return false, and not lower will get printed out. Now, just as is lowercase exists, so also is uppercase exist. Character.isUppercase returns true if the parameter is an uppercase letter and returns false if it is not. So for this program, if it returns true, we'll simply print out is upper. If it returns false, we'll output not upper. So let's run it. We prompt to enter a char. I enter uppercase T. Clearly, uppercase T is an uppercase letter. Thus, the method will return true, and is upper will get output. I run the program again. This time, I enter lowercase t. Obviously, lowercase t is not an uppercase letter. Thus, character.isUppercase will return false, and not upper will get printed out. I run the program again. This time, I enter the number 5. Obviously, number 5 is not an uppercase letter. Thus, character.isUppercase will return false, and not upper will once again get output to the screen. So, now that we've seen several ways that the character class can be used to determine the property of a character, now we're going to explore a couple ways the character class can be used to change the property of a character. For example, the character.toLowercase method. The character.toLowercase method, what it does, if the parameter is an uppercase letter, it'll return the lowercase version of that letter. If not, it'll just return the same exact character. Okay. So, suppose I have a program that, once again, asks the user to input a character, receives it, stores it in a char variable. I pass that to the character.toLowercase method, store the result in a second char variable, then print it out. Let's see what happens. I execute it, enter a char, I enter uppercase F. Since I entered an uppercase letter, character.toLowercase method will convert it to the lowercase f and store that inside ch2. Thus, lowercase f will get output. If I run this program again, but this time entering lowercase e, well, since e is already a lowercase letter, there's nothing to change. Thus, lowercase e will get stored inside ch2, and that's what will get output to the program. Suppose I run this program again, but this time I enter the @ symbol. Obviously, there's no lowercase version of the @ symbol. The @ symbol is not an uppercase letter, thus it'll not get changed. It'll get stored inside the ch2 variable, and thus it'll get output again. Now, just as we have a character.toLowercase method, so also we also have a character.toUppercase method, which if its parameter is a lowercase letter, it'll return the uppercase version. Otherwise, it'll return the same exact character. So, running the same program as we did before, but now with the two uppercase method, if we execute it, enter a char, if I run it and enter a lowercase n, since n is lowercase, the method will convert it to its uppercase version and store that inside ch2, giving us uppercase n for our output. Suppose I run this program again, but this time entering uppercase R. Since the input is already uppercase, there's nothing to convert, it's already there, thus it'll not get changed. Uppercase R will get stored inside ch2, and thus that'll get output to the program. Okay. Now suppose I run this program a third time, this time entering the percent sign. Obviously, this is not a lowercase letter. Obviously, there is no uppercase version of the percent sign, thus the character will not get changed. It'll get stored inside ch2, and that's what'll get output back to the console.